All right, in this video, we're going to cover how to configure DHCP on your routers. And in this instance, we are going to have just one of these routers here is going to provide DHCP services for our entire network. So there's a little DHCP sign right there. So the steps to configuring DHCP, first things first, you need to enter a global configuration mode. And the command is IP DHCP pool, question mark there. So it shows a word here. They want you to supply a name for this DHCP pool. I would recommend, you keep it easily identifiable with what it should be going to. So, like for instance, we call PC's VLAN 10 because it's on the 10 network. We have a sub interface right there that's 10. I'd recommend keeping this either 10, something you can easily remember, or even going in VLAN 10. Just keep it so it makes sense to you. It's easy to see and identify when you do a show run command or a show IP DHCP pool command. So when you enter that command, IP DHCP pool, and you give it a name, you enter the DHCP configuration interface. It's a question mark here. So there's not a lot of settings you really need to set in here. So you have default router, so that's your default gateway that your DHCP clients will have set for their network configuration. The DNS server they will have set, and the network that this will create from. So we can go in here and we'll do a network. You see it wants a 4-octet network, so we're going to give, let's start with, we're doing VLAN 10, so we want 192.168.10.0, and now it wants the network mask, so 255.255.255.0. The next command we need to give is the default router, so that the PCs or the laptops that are DHCP clients know where to send traffic that's destined for outside their network. And again, that's going to be the first IP address. I guess it doesn't necessarily have to be that first IP address. I guess you could go in and give your router an IP address of, here your sub interface of 192.168.10.53. Best practice would be give it .1. So your default router should be 192.168.10.1. And it should be that for best practice, but if you go in, you hover over this address here, and you see the gigabit 0/1.10 there is not 192.168.10.1. Don't give that as your default router. You want to make sure that it matches the actual router's interface IP address. In this case, we did it properly. It is .1. We'll give a DNS server. Now for this, you can just pick, you pick 1.1.1.1 or 8.8.8. Any well-known DNS server is fine, or you really can make it up. There's no NAT to the PC protocol inside of Packet Tracer, so you can't get to the web anyway on here. But for practice, you should know how to set this. So we have the 3 commands we need to know: DNS server 1.1.1.1, a default router, so it has PCs know the proper default gateway, and the router that the network that this belongs to. And that's all we need for this one instance of it here. So let's see. Let's take a look at that again. All right, well, let's see why this is failing. So we're put this on static. We'll go to simulation here and watch it go on DHCP. It's already canceling back. What's going on? Oh, that's great. So from a previous lab we were just talking about, we still have an access list that is just blocking this communication by default and keeping it from going outside the router. So I'm going here. Okay, here we're going to go no access list 110. There we go. Let's real time this again. Let's check it out. There we go. All right, it's always fun troubleshooting this on the fly. So we have this set up and running, but now we need to get one for the laptop as well. So let's head back in here, IP DHCP pool. We're going to give it a name that makes sense, VLAN 20. We need to assign the network that this should be providing addresses for, network 192.168.20.0, the subnet mask. As well as the default router, which is your default gateway for the PCs, 192.168.20.1. Again, this should be the first available IP in your network, but if you configured it differently, then make sure you are setting the IP address that it actually belongs to the interface that your network is connected to. And DNS 1.1.1.1, and that's it for the VLAN 20 here. Now, if we want to, we could just go through, if we didn't explicitly say we want this to be our DHCP server, we could put two more pools on this router, two more pools on this router, but we want to put everything on this one centralized DHCP server for us. So we're going to go through and we're going to create 4 more pools. Now, here's where just up arrowing saves time. IPGC pool VLAN 30 for the name. It's going to hop into that configuration interface. Same DNS server, that's fine. We're going to change our network to .30 for the default router. Then the network command, we're going to make that .30 as well. All right, let's up arrow again. Let's change this to VLAN 40. Default router 40.1. Network 40.0. The same DNS server. Up arrow again. We're switching to 50s now. VLAN 50. Same DNS server is fine. Change our network to 50. And we're going to change our default gateway to 50. The last one, we're going to do R60. And you can see after you do this one network, it's really easy to get the rest of yours configured out and ready to go. And let's give them the same DNS server. All right, so there we go. So now we have 6 DHCP pools. Out of here, do a show IP DHCP pool. So we see we got 60, 50, 40, 30, 20, and 10. And below each one, we can see, we're not excluding any addresses here, but the IP range is from 1 to 254. This has 1 active lease right now. None of these have active leases yet. There we go. So these two are going to work fine here, but we're going to run into a problem when these clients over here try to get DHCP addresses, because by default, routers block broadcast messages. So a DHCP request is a broadcast. So these PCs here are going to send it out, and the router is going to drop it and say, I don't have a pool for you, because it's not going to keep forwarding that traffic around. We have to use what's called a helper address. So you need to go into the sub interface that is going to be on that network. Go interface, gigabit, 0/1. Since we always stick with calling them, to a name that makes sense. So .1, .40 for the 40 VLAN here, .30 for the PC VLAN. We're going .30 for the PCs. And the command we want to use is IP helper address. And what you need to do is point to the closest interface of your DHCP router. So Our serial 000 is 10.0.0.1. So we're telling us 10.0.0.1. There we go. Let's hop into our 40 subinterface. And it's going to be that same helper address because we're going to be sending every DHCP packet that comes through to 10.0.0.1 here. So this router can handle it. We're going to do that on the other two subinterfaces as well. So interface gigabit 0/1.50 IP helper address 10.0.0.1. Let's hop into the 60 address, and we're going to give it the same helper address. So what these helper addresses do, they sit here right on this interface, and when a DHCP broadcast comes through, instead of the router just dropping it like it wants to do with broadcast address, this helper address says, okay, well, certain broadcast address like DHCPs, go ahead and forward them to this address here, and that's our DHCP server. This will allow the hosts from other networks outside of the normal broadcast domain actually be able to reach a DHCP server. So let's check and see here. Set static DHCP. Let's see if it gets its DHCP address back. And there we go. It's got 60.2. So the one thing not included in this lab you can also do, we're going to need to exclude some addresses. So let's go in here and do config t IP DHCP. And so we don't have to go in per pool and tell the pool what addresses to exclude. You can do this from the global interface command. So let's say excluded addresses. And the first address, so question mark here, is the low IP address. Let's say we want to do best practice and just block off the first 10 for all your network services, 192.168.10.1. And then it wants the high end range, so 192.168.10.10. There we go. Now we know the next IP address that comes out will actually should be .11. There we go, .11. And sometimes people will exclude the last 10 because you want all your switches to be the last 10. You want your network services to be the first 10. It's really up to you. But to exclude addresses, it's really simple. It's an IP DHCP excluded address. You don't have to go into your individual DHCP pools to accomplish that. You can just type those in from the global config IP DHCP excluded address 192.168.20.1 through 192.168.20.10. There we go. Now we have those 10 addresses also excluded.